Everyone, in this video, let's continue in number 5. A 79.9 cubic centimeter sample of oxygen is collected by water. So it's collected by water. So this is Dalton's partial pressure. Displacement at 24 degrees Celsius. What volume would the gas occupy at standard pressure if the gas is collected originally at a pressure of 98.5 kilopascal? So this problem is the combination of Dalton's law of partial pressure and Boyle's law. So number 5. So the volume 1, this is a volume 1 here, which is 79.9 cubic centimeter. So the volume 1 here is 79.9 cubic centimeter. And the pressure 1, which is 98.5 kilopascal. So the pressure 1 here is 98.5 kilopascal at how much temperature, which is 24 degrees Celsius. So 24 degrees Celsius. This is a collected over water. Collected over water. So this is a pressure 1 and a pressure 2 at standard temperature pressure. This is standard pressure here. Standard pressure. So this is our pressure 2. Pressure 2 is equals to 101.325 kilopascal. So the unknown is the volume 2. Volume 2 is the unknown. Because what volume? So the question is what volume here? What volume would the gas occupy? Okay. So the question is volume 2. So let's use Dalton's partial pressure as a solution here. First thing we need to do is we need to use the vapor pressure of water in Dalton's law of partial pressure. So in pressure 1, we have 98.5 kilopascal. So 98.5 kilopascal. There's a formula here. So P1 equals to P gas equals to P ATM minus P water vapor at 24 degrees Celsius. Okay. So P gas, how much P ATM here, which is 98.5 kilopascal. So 98.5 kilopascal minus the P water vapor at 24 degrees Celsius. So let's find here at vapor pressure of water. So it's 28 degrees Celsius. No, it's 24. Sorry. 24. So it's 24 here. 24 connects to 3 kilopascal. Okay, it's 3. So minus 3 kilopascal. So P gas is equals to 98.5 minus 3 is equals to 95.5 kilopascal. So that is a pressure 1 is equals to pressure 1. So our pressure 1 is equals to 95.5 kilopascal. So in pressure 2, we have standard pressure. So let's use the Boyle's law, which is P1 B1 equals to P2 B2. So we need to divide both sides by P2 and P2. So cancel out P2, and the volume 2 is equals to P1 times B1 over P2. So volume 2 is equals to, what is the pressure 1? The pressure 1 is 95.5 kilopascal. So 95.5 kilopascal times the volume 1, which is 79.9 cubic centimeter. So it's 79.9. 79.9 cubic centimeter divided by the pressure 2. When the pressure 2 is 101.325 kilopascal. So it's 101.325 kilopascal. So you need to cancel out the kilopascal. On the left is cubic centimeter. So 95.5 times 79.9 divided by 101.325 is equals to 75.30 cubic centimeter. So that is your final answer. Okay, that's a volume 2. So let's continue in number 6.